in the background. So remember, Q1 is the same with P25. Q3 is the same with P75. And some of you on the midterm did not identify that this is not the majority, not some of the data. This is exactly 50% of the information in the data set. Many of you identified it correctly. And before we go that, I don't want to forget, there was one problem with a skewed distribution that I want to just make sure. Many of you said the median is higher. Well, we know that the mean is higher than the median. Okay, so the mean is higher if it's skewed to the right. And also, some of you, I would say many of you, consider the spread of the data like the mean or the median. No, the spread of the data is either sigma, which is the standard deviation, or the IQR. When we talk about the spread, we're not talking about the mean and the median. The mean and the median are the center, measures of center. Measures of spread, sigma and IQR. If it's skewed, either right or left, we use IQR. If you go back to your notes or my notes that I posted, this is for the measure of the spread for a skewed distribution, IQR. So please don't say that the spread is the mean or the median. No, these are measures of the center of the data. Okay, enough of that. Let me share my screen and go to 7.2. You said, where is my, okay. 7.2. Okay, homework, right? Not interactive.
Right, homework.
Okay.
There's the very last question of 7.2.
Yes, let's take a look and see what it does. No, I didn't mean that. Okay. Identify which of the following is not a property of the standard normal curve. So remember, where are my, so when we listed bell-shaped, symmetric, let me stop sharing for a second, right? Bell-shaped, symmetric, the empirical rule, area has to be 1 and only positive because we're talking about probabilities. So now let me go back and see what, okay, as the value of z increases, the graph approaches, but never equals 0. Of the standard normal curve. So yes, we're talking about z. Yes, correct. Okay, yes, as the value of z increases, the graph approaches, but never equals. So choose the correct answer below. So this is correct. Let's read on. The mean, median, and mode are all equal to 0. Yes, that is correct. It has inflection points at no. No, the inflection points are still at mu plus or minus 1 sigma. It is symmetric about its mean of 0 and has standard deviation equal to 1. Yes. Identify which of the is not a property. This is it. So A is correct. As the values of z increases, yes, the graph approaches but never equals 0. Correct. The mean, median, and mode are all equal to 0. Yes, absolutely true. The inflection points, no. Like for any normal, including standard normal, the inflection points are at mu plus or minus 1 sigma, not 2 sigma. And it is symmetric about its mean of 0 and has standard deviation equal to 1. Absolutely true. This is the only one that is not correct.
Wait, Professor, that was question 1. Didn't Gabe have a question about question 20?
Yeah, it's the last question.
Some people cannot make a difference and don't understand the difference between 1 and 20. I'm one of them. I'm sorry. The number of chocolate chips in a bag of chocolate chip cookies is approximately normally distributed the mean of. So every time, don't let me go on a rant like that, explaining stuff. But that's good. So I have to, so this is the mean 1262 and 118. So normal, mean, I have to say this because this has just happened with you. So I don't remember where I read this. Just recently, last week, it said, "Life is short. If you cannot laugh at yourself, call me. I will." So see, I don't have to call you. Okay, sorry about that. Let me go back and share. Good. So I made a note, normal distribution with mean 1,262 and the standard deviation. Good. Determine the 30th percentile for the number of chocolate chips in a bag. Excellent question. So we want to determine the 30th percentile. Okay. I don't think we did a problem like this in class. Excellent question. So this is the probability. This is the normal curve with a mean 1,262 and standard deviation 108. Okay, so now we want to determine P30. P30 means this is 30%, and the rest, how much?
70.
Good. So now I have the area this time. The area is 0.3. Okay. Excellent question. I'm going to share my screen and go to the calculator. Okay. So in the calculator, go back to second and distributions, and this is what is called inverse norm. I don't want the area. This one gives me the area. This one, I give the area to determine the observation or where the observation should be. It may not be an observation from the data set, but it will tell us where it should be. So with inv norm, so select 3, area to the left, 0.3. The mean, no, is 1,262. Standard deviation is 118. And yes, we are looking at the tail left, yes. Area to the left, paste. Okay, this is it. So area to the left, mean, standard deviation, and I guess these newer calculators can do whatever else. But with the older calculators, you always have to give the left area, not anything else, in order to determine the inv norm. And you press enter. And we get that, let me, so this is 1200.12. So this is what it means. It means that this point here, which may be an observation from the data set or may not, is the 1200.12. So I determined with inv norm with the area to the left, 0.3, and then mean and standard deviation. And for some more than, I mean, the older calculators do not require anything else. So the area to the left, mean, standard deviation, close the parenthesis, and that's it. So now I'm going to share again. I'm not sharing what I want to share. I want to share this. Okay. So round to the nearest whole number as needed. So that is 1200. Where's my keyboard now? Okay, I got it. Okay, then determine the number of chocolate chips in a bag that make up the middle 97%. Okay, very good. I'm going to stop sharing. Okay, I'll graph it again so we understand what is happening here. So this is the middle 97%. So they want, I'm sharing again, they want again, determine the number of chocolate chips in a bag that make up the middle 97%, right? They are not, so what I need to determine is, using inv norm, the left and the right numbers. So if this is 97%, this piece and this piece are equal, and their sum is 3%, because 100 minus 97 is 3. So this little piece is 1.5%, which has to be entered as 0.015, and I have to determine this with the left area, and in order to determine with the inv norm, of course. So for this one, inv norm, for everyone will be 0.015. Mean, what was it? 1262, yeah, comma 118. And if you have the new calculator, whatever, left area. And for this one, so this will be this. And for this one will still be inv norm, the area to the left, because I have 0.97 and plus 0.015. You don't have to calculate. I'm just putting it here. It will the calculator will calculate it. Well, we know how to calculate this. Comma 1262118, and this will give us this number. Once I have this and this, from the bigger one, I subtract this one, and I know how many chips were here between these two. But I have to determine this, and I have to determine this. I can do it in one line. I don't have to determine specifically unless I'm asked to. Okay, so let me share, and we go back to the calculator. So I want inv norm. So inv norm, I want this to be copied. And I just go in and I will put the bigger one first, but it doesn't matter. I can put minus for the other one. It doesn't matter. So I'm going to delete this number and enter. That's how lazy people do it. So I have 0.97 plus 0.015, and that will give us the first one, the bigger one.
You have 2 points near the 97.
Oh, I do have 2 points. You will not like it. Thank you. He will definitely not like it. Thank you. And then minus the small one. Unless the problem is asking us to determine those. If it doesn't ask me to determine those, then I'm fine.
Question.
Yes.
Does the 0.05 go for all questions? Like even if it's not 97, it's 98?
If it's 98, then I have 1% and 1%.
Okay.
The area is 100.
Oh yeah. Okay.
The area cannot be anything else but 100. Otherwise, it's not a probability distribution function. So I got that the number of chips in this distribution between this and this, between 97, middle 97, 512. The number of chocolate chips in a bag that make up blah, 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 blah. Oh. See what happens when people don't read? Okay, so then I'll go back and I will redo. So that I can determine with no problem right away. Okay, so it's 1,000, the big one, 0.93. And let's see the middle. I will just copy the entry and change this into 98, right? So we have 0.97 plus 0.0. That's what it is. So enter. Okay. So 1518.07. And then I'll go in and I'll put it in. So is to this. So they want the smaller one first, which is 1, round to the nearest whole number, 1,006 I got. And the other one, 1518. Good. And now let's see part C. What is the interquartile range of the number of chocolate chips? So now you understood. So this is not asking us to find Q1 and Q3. This time they want exactly what I did initially. So let's go back. So I'm going to, as I said, like lazy people do it like that. And I'm going back. Does it allow me to go back? It doesn't. Okay, never mind. So So we want the inf norm for Q3, which is 0.75 with all that, minus, same thing, inf norm with 0.25. Area to the left always. And this calculator can do center and right. I'm showing for the old calculators as well. So this is how it's done for the old calculators. Only with the area from to the left. And when I press enter, I get 159.18. So let's see how they want the answer. I'm assuming also an integer. The interquartile range of the number of chocolate chips is round to the nearest whole number, of course, 159. Very good question. Thank you. This is the way to go. That's why I'm kindly asking you to keep up with me and not forget and not fall behind, so we can analyze anything that we didn't get the chance to look at in class.
Sorry. So one more thing. I was doing this on StatCrunch. So Q3 is just 75 and Q1 is 25%.
Yes?
Okay. Perfect. Thank you.
Yes. So let's go back here. Let me stop sharing. So here it is. Q1 is P25, Q3 is P75. So one more time the graph. So this is the 50%, 50-50. Here is Q1, here is Q2, and here is Q3. This is the same with P25, this is the same with P50, and this is the same with P75. Meaning, this is 25%, this is 50%, and this is 75%. And of course, the complement is obviously has to add up to 1.